Okay, so we are going to sketch the graph of the polar curve r is equal to 1 plus sine theta. So instead of using a table of values like we did in the previous example, we're just going to use the graph, the Cartesian graph of r equals 1 plus sine theta. So that's already shown here up in the upper left corner. And be careful to note that, this graph up here in the left corner is not the graph of the polar curve, right? So this is just like, this is our r equals 1 plus sine theta, where r is the y-axis, right? And theta is the x-axis. So this is exactly the same as what y equals 1 plus sine x would look like if, we had theta equal to x and r equals to y, right? So let me just get rid of all that stuff. We're going to use this graph just the same way we use the table. So just to tell us kind of how the value of r is changing as theta goes from 0 to pi over 2 to pi to 3 pi over 2 to 2 pi. So what we can kind of do is look at this kind of piece by piece. So for example, on this section from 0 to pi over 2, let's call that just 1 here, right? We have on section 1, as theta goes from 0 to pi over 2, r goes from, so that's a theta right there, right? R goes from 1 to 2, right? And then we can continue, this, for all these different values where there's some kind of significant change in the value of r, right? So we're not doing this for like every single part. And then this fourth part will just be from 3 pi over 2 to 2 pi, right? So we're not, looking at a ton of specific values of theta. We're just looking at these main values of theta where there is some change in r that is, significant. So on 2, we have theta going from pi over 2 to pi. And r decreases from 2 down to 1. Right? And then on 3, we have that r goes from 1 to 0 as theta goes from pi to 3 pi over 2. And then on this last little section, theta going from 3 pi over 2 to 2 pi. R is going to go from 0 to back up to 1. Okay. So we have, we can kind of look at this in sections, right? So now let's actually graph the thing. So we start at theta equals 0, right? So this is just going to be this first part. And r is going to go from 1, increase from 1 up to 2, right? So it's, I don't have it marked here, but let's say 2 is around here. Right, so we're gonna go from 1 up to 2, right? Let's try to do that a little bit better. 1 to 2, right? And you see you have this behavior where the value of r, right, is increasing. The distance, right, from the point on the curve to the origin, right, is increasing from 1 to 2, right? So the lengths of these lines are going to increase from 1 to 2. So you have this curvy part, right? It's not like a straight line. Okay, and then on the second portion, we're going from pi over 2 to pi, and r is going to go from 2 back down to 1. Again, I don't have it marked, but let's see, about here, right? On the x-axis, that would be -1, right? But that's just a distance 1 away from the origin, right? So we're doing the same thing. We're going to decrease from 2 to 1, like that, right? And now for the third part, right, so this is, if we wanted to like label it, right, this would be like 1, this would be like 2. The third part is going to be what happens from pi to 3 pi over 2, right? So it's what happens since we have a positive r for all values here. This is going to be, the third part is going to take place in the third quadrant. And so we go from 1 to 0, right? So again, making note of this curvature, right? And then our last part is 4 here. And so it's going to go from 0, r is going to go from 0 back up to 1. So it looks something like that, right? So that's our curve here. You didn't need to necessarily like write out all of this stuff here. That was just so that you can visualize exactly what we're doing. But it helps to kind of, if you're going to just use the graph, the Cartesian graph of your curve, it helps to kind of segment the parts, right? So you can see what's happening maybe in the first quadrant, second quadrant, etc.